Hello, my name is Daiva Nakučionienė. I'm from Kaunas, Lithuania. I'm a full professor at Kaunas University and Technology Department of Production Engineering. My research and training areas include development and investigation of protective and medical textiles, as well as knitted structures with wearable electronics, and of course, sustainability in these fields. For the CleanTex course, I've prepared and will introduce you the second unit entitled Knitting and Weaving Processes in Circular Economy of the Module 5, Sustainable Yarn, Fabrics, and Garment Assembly Production. So let me share the content of this unit. So the content is knitting and weaving processes from the beginning to present day, monitoring and control of process parameters that can reduce waste cost and environmental impact, circular weaving in the context of waste management and production efficiency, fully fashion knitting in the context of waste management and production efficiency, and seamless and whole garments knitting in the context of waste management and production efficiency. Woven fabrics are known for more than 25,000 years ago. There is no information on how these Paleolithic fabrics were manufactured. Likely, they were manufactured like hand weaving without any looms. The first information which reached us from previous centuries shows that the first weaving loom were vertical as presented in the picture from ancient Egypt civilization from more than 5,000 years ago. Such weaving was really completely wasteless, as all yarns were woven into a fabric and even small ends of yarns were used for manufacture. Unlike spinning or weaving, knitting doesn't figure in any ancient myths. In fact, there isn't even an ancient Greek or Latin word for knitting. The word to knit was not part of any European language until the Renaissance. All this confirms that knitting is a relatively new invention. The history of knitting is believed to have begun in Egypt in about 400 of years of our era. Until the 16th century, knitting in Europe was exclusively male work. This was particularly evident during the 13th to 16th centuries, when knitting guilds were conceived around Europe, particularly in the United Kingdom. Each guild established a distinctive reputation with regard to the quality of knitting it produced. By the 13th century, socks were mostly knitted as flat products with a seam, and from the 15th century as circular knitting using 5 knitting needles. The first mechanical stocking frame knitting machine was invented only in the year of 1589 by William Lee in Nottinghamshire, England. Its principle of operation is still used today in wet knitting machines. At the time of its invention, politicians argued that if the machine was adopted, the art of hand knitting would be abandoned and converted to the factory system. This thinking continued into the late 18th and early 19th centuries, despite the fact that technological development promised expansion, growth, and prosperity. The stocking frame knitting machine allowed larger quantities of garments to be produced in shorter periods of time, combined with lower labor costs. Mass production technology grew with the advances of the industrial modern age, including the ongoing creation of machines and the steam engine. It is known that monitoring and control of technological parameters can reduce waste, cost, and environmental impact. One of the factors that is controlled during knitting or weaving is yarn consumption. Also, dimensions of a knitted garment. The dimensions of a knitted garment are difficult to control because of its elastic nature. If two garment samples are knitted with the same yarn and structure but have different dimensions, it indicates a difference in the length of the loop or the density of the stitch. In this case, the knitting machine settings need to be adjusted. During the knitting process, yarn consumption can be minimized in knitting by effectively analyzing the yarn feed through the computerized system of the knitting machine. For managing time and yarn waste, it is important to control possible knitting defects such as broken needle, yarn fly, hole, bare, and record-thin yarn segments. Bare means a continuous visual bird pattern or strap lines parallel to the yarn direction in a knitted fabric. It is usually caused by different tensions of the yarn among feeds. The cause of a fabric hole is a broken needle. The defects of the thick and thin yarn segments directly depend on the quality of the yarn. Defect in the knitted fabric mean that these defected pieces of the fabric will increase the total amount of knitting waste. In fully function and seamless knitting, such defective pieces usually are disassembled and the yarn is reused for knitting, significantly reducing amount of knitting waste. Everyone thinks of a revolutionary method to minimize the production cost. In the existing garment production system, the cutting and sewing process is mainly labor-oriented. The sewing process also may create a needle hole in the sewn product that reduces marketability. The stress created at the seam portion will also lead to failure in the garment. Finally, cutting and sewing is a labor-intensive process that creates human errors, and then the cutting process creates more fabric wastages. In addition to offering high comfort and better fit to consumers by eliminating seams, the innovative seamless knitting technique creates entire garments with minimal intervention of cutting and sewing processes, leading to savings in cost and time, higher productivity, quick response, and just-in-time production. Seamless garments have no waistband or side seam failures. Seamless garments take 30 to 40% less time to produce than cut and sew versions, as they minimize the traditional labor-intensive steps of cutting and sewing. Seamless garment technology is an advancement in the apparel industry that eliminates the fabric laying, cutting, and sewing processes. Thus, seamless knitting eliminates processes that create human errors. Since each garment is produced based on digitally programmed data, item to item, and batch to batch, quality even for repeat orders remains consistent. Yarn Bank is an idea presented by Šimaseiki. It is the first free of charge website to search and download digital yarn data that can be used for virtual sampling. Downloading yarn data reduces the need to scan yarns manually and improves the accuracy of simulations and the efficiency of product planning. The biggest attention in weaving modernization in front of sustainability and wasteless manufacturing is given in a non-stop procedure of weaving when one beam is changed by the similar next one, and ends are tied directly in a loom, while the ends of the yarns in the bobbins after beam formation could be used for the manufacture of woven fabrics as warps. However, not all kinds of warp yarns can be used for webs. Therefore, some amount of waste usually appears in this process. In weaving, minimization of yarn consumption can be achieved by minimizing the length of side-left waist. In the Picanol weaving loom, the EcoFuel system was introduced with a main focus on applications where high-value webbed yarns are used. It eliminates the catch cord system and reduces filling waste. The next step is to recycle the wet yarns waste. In air-jet weaving looms, it is realized by using cordless system. At the end of the insertion, the filling yarn is stretched and guided into a suction mouth. The remaining ends of the filling yarn waste are then removed and ready for recycling. Air-jet machines need waste lines to remove filling yarn waste. This requires extra devices as well as catch cords from flange of horizontal bobbin stand. The waste length then needs to be guided towards the waste bin. The Picanol AirMeister allows the measurement of air consumption as well as detection of leakage and blockage. The data measured by the electronic air consumption meter are processed by the machine. This makes it possible to offer continuous measurement of air consumption, fully automatic diagnosis for leakage and clogging detection, and to manage the length of the filling to reduce waste. Vertical type of weaving looms existed until the beginning of the Middle Ages, when a horizontal loom with wall beam was developed. Ancient vertical weaving looms were really wasteless, as warps and threads were used up to the very end. Horizontal weaving looms is not fully wasteless, even in the case of hand looms, as some part of yarns from the beam are not used for fabric weaving. The beginning of warps and the ends of warps on a beam cannot be used for weaving. Also, there are ends of wefts left on both sides of a woven fabric. In many cases, catch cords are used, which also create additional amount of waste. Picanol manufactures high-tech weaving machines based on air-jet and repeat technology. The difference between these two types of machines in regard of reduced amount of waste is in the principle of weft insertion. Using rapier or shuttle weaving technology, ends of wefts left on both sides of woven fabric are very short, while in air-jet technology, they are relatively long ends of wefts left on both sides, which are cut directly in weaving loom, and it is a pure waste of yarns. Even modern technologies of classical weaving did not fully solve waste problems in weaving. Even more, in modern technologies, waste rises not only in weaving looms, but also in a process of beam manufacture. Not all yarns from bobbins in acrylic are used for beam manufacturing. Therefore, we cannot say that modern weaving is fully wasteless and sustainable. In order to reduce the amount of warp yarn waste, bobbins of higher mass and with higher lengths of yarns on them are used for warp beam formation. In this way, it is possible to reduce the number of bobbins with residue of yarns left after beam formation. The biggest attention in weaving modernization in a front of sustainability and wasteless manufacturing is given in a non-stop procedure of weaving when one beam is changed by the similar next one, and ends are tied directly in a loom. These ends of the yarns in the bobbins after beam formation could be used for woven fabric manufacturing as warps. But not all kinds of warp yarns can be used for wefts. Therefore, some amount of waste usually appears in this process. The most wasteless and sustainable weaving is circular weaving. When woven fabric is manufactured like a circle tube directly from a quill, that is, a warp beam is not used, and it helps to reduce waste of yarns used for warps. In addition, in this mode of weaving, it is possible to avoid the waste of weft yarn ends. It is necessary to mention that such kind of looms is used only for very narrow technical application, for sacks, for tube reinforcements, and other kind of technical fabrics. The amount of such kind of fabric is less than 1% of all woven fabrics in the world. Talking about knitted garments, it is necessary to say that knitwear can be produced using three methods: cut and sew, knit to shape and sew, and seamless. The cut and sew method involves knitting a panel fabric, cutting out the garment pattern, and then sewing. Cut and sew produces the most waste amount as compared to the other two methods. The amount of fabric waste can even be up to 30%. The knit to form or fully fashioned method involves knitting the garment panels to the exact shape required for construction. The highest amount of fabric waste in this case is 3 to 5%, depending on the technical possibilities of the knitting machine and the complexity of the shape of the panel. Seamless knitting was developed to achieve more efficient and less costly production, that is, to be able to cut down on the cost of cutting and sewing when making knitted garments. It was also developed because of the functionality, no seams in small, narrow items. Technical waste using this method is less than 3%. The high amount of waste in the traditional clothing industry is a big problem, and it can be solved by using fully fashioned method. However, this technology requires automated and computer-controlled knitting machines. The fully fashioned knitting of regular details and seamless knitting technology shortens the manufacturing process and significantly reduces material waste. A new way of making garments also opens up new ways of thinking, which may lead to new expressions. Fully fashioned technology allows to get fully fashioned panels of garment that do not require cutting operations, or cutting is used only for small corrections, such as shape of neck holes and armholes. The knitted panels usually have all necessary parts, such as pockets, buttonholes, even collars, which are also knitted during the same knitting process. Additionally, fully fashioned knitting panels can be unknitted if some knitting defects appear by using these yarns for knitting repeatedly. However, only part of the seams is eliminated in fully fashioned technology. Cutting operation is still required to trim the fabric area outside the garment panels, and sewing is needed to join components together into a garment. Panels knitted with fully fashioned knitting technology commonly are connected to each other through locking courses, as the main problem in complete garment knitting is fabric take-up realization. Locking courses are knitted using different yarns from those used for the main part knitting, and they are mostly cheaper than the main yarns. The locking courses helps to avoid take-up of the first courses of each panel, and what is also very important, protect the knit from unstitching after detachment of two adjacent panels. Detachment is very easy to perform by pulling yarn out of the locking courses, which is bent into much longer loops than the loops in the main part of the panel. Several knitting parameters can affect the dimensions, appearance, tensile properties, and tactile comfort of a garment. These include combinations of stitch types, loop formation, yarn types, machine settings, and design processes. The shape of the fully fashioned knitted pieces can be changed in different ways. Different knitting patterns can be combined in one panel. Usually, such a combination includes patterns with the same number of wheels, but different effect on vertical and horizontal dimensions. In the presented sample, in the figure 20, rib 1 by 1, plain jacquard, and lace patterns are combined together. Additionally, yarns with different liner density or yarn diameter can be used for different parts of the same knitted panel. Different loop lengths and different widths of a panel can be obtained by using multi-gauge flat web knitting machines. Also, loop transfer from needles to needles allows to get interesting design as well as to change dimensions of a panel. Fully fashioned garments can be developed through knitting technology by widening or narrowing the fabric by doing the loop transfer. Loop transfer is move of the stitches between the needles. This helps to eliminate cutting operations by changing the number of knitting needles and knitted waves. If new needles are added to the knitting zone for widening, a yarn can be simply laid on the newly added needle, or some group of the loops can be transferred onto the adjacent needles. To narrow the panel, one or group of the loops are transferred onto the adjacent needles and knitted together with the loops that were knitted on the recipient needles. Here, the principle of the narrowing is presented when only one loop is transferred onto the adjacent needle in each or every second knitting course. On this slide, a principle of narrowing is presented when some group of loops is transferred onto the adjacent needle in every second knitting course or after some number of courses repeatedly. It not only changes the dimensions of the panel, but also can give very interesting design effects. Each panel of the garment can be knitted on separate knitting machines, or all panels of the garment can be knitted on the same knitting machine. However, the first method is usually used. Typically, a knitted garment consists of separate parts, the front and back body panels and the sleeves, which are sewn together afterward. It requires highly skilled sewing labor. Seamless knitwear is produced in one entire piece three-dimensionally directly on the knitting machine. Sometimes it requires inexpensive post-production labor, such as partial stitching, realizing a whole new kind of knitwear. Seamless garment technology is an advancement in the apparel industry that eliminates the fabric laying, cutting, and sewing process. Ultimately, we can minimize the production cost as well as production time by 40% compared to the existing apparel production system. In addition to that, a seamless garment gives more comfort because it does not have a seam in its structure. The dimension of seamless knitting creates clean shoulder lines and produces a garment that is better suited to the shape of the body. In addition, eliminating the seams under the arms also eliminates the bulky discomfort of typical sewn knitwear. Also, knitted necklines and collars create a sophisticated look of a garment. Seamless knitting technology brings an innovative concept in clothing manufacturing and enables to have different pattern structures in different areas. For example, a jersey knit can be placed side by side with a mesh knit, which can be placed side by side with a rib or jacquard knit with an embroidered like logo. Also, it enables to have different kind of yarns in different areas, better and wider range of fit, freedom of movement and comfort, as well as custom apparel at a good cost. The fully fashion and seamless nature of knitting also ensures continuity of the fabric, allowing functional yarns such as those made from conductive fibers to wrap around the entire body without interruption for applications in smart garments and wearable technology. Previously, seamless garment manufacturing was limited to underwear. Due to the unlimited pattern possibilities, seamless technology is now being employed to manufacture very exclusive outerwear, compression garments, and garments for sportswear. Also, the seamless technology is being used for protective garments, maternity care, support care garments. Innovative warp knitted garments can also be produced in a single sequence without any seams. They can be used in functional sportswear, underwear, hosiery, and fashionable outerwear. Because more brands are producing products without seams, consumers are willing to pay more for greater comfort and softness. People are more appreciative of the sustainability movement behind technology. Because of a more ethical and eco-friendly lifestyle without compromising quality or design, seamless garments are definitely a contender for consumers. New technologies have unique advantages, both commercial and economical. The seamless technology is also no exception. Seamless knitting benefits everyone, designers, manufacturers, and consumers. It gives, first of all, freedom of body movement. Generally, the seam portion of any garment does not have the same elasticity as the body fabric, so the difference in elasticity will affect the movement of the free body. Also, inherent softness, because there are no bulky and annoying stitches at the underarms, shoulders, and necklines, which may cause irritation to the wearer. Seamless garment technology creates new design possibilities and diverse design structures. Also, it caused a supply chain revolution. This technology improved planning accuracy and efficiency through the use of virtual samplers, minimized post-processing, and reduced lead time. Bottlenecks in the supply chain caused by labor-intensive cutting and sewing processes are eliminated. Seamless knitting enabled procedures to forecast demand and also quick response to support mid-season production and customization. Optimized inventory prevents leftover stock. Seamless knitting ensures air-ready manufacturing by using minimal resources. Beyond comfort, seamless garments are also sustainable. The following sustainable advantages we can find from seamless technology. First, reduced labor cost. Due to elimination of cutting and sewing processes, it is obvious that reducing more labor involvement is necessary. Second, minimum yarn consumption. Most of the fabric wastage occurs in the cutting stage. Since seamless garment excludes this process, the fabric consumption per garment is less, so the yarn consumption is also very low. Third, smaller workspace. As the number of sewing operations is less except for a few cases in the garment production system, it leads to a smaller space requirement. Fourth, reduced yarn and fabric inventory. The cutting and sewing process requires more fabric and yarn inventory. Due to the absence of this process, there is no need to maintain a large inventory. Fifth, quick sampling. Sampling is a costly and time-consuming process because a small portion of fabric and accessories must be prepared. Sixth, fewer product failures. Most garment failures are due to seam failure. The seamless garment does not have seams, thus garment failure is also very less. Seventh, less cost of production. This leads to savings in production cost up to 40% compared to the customary garment production systems. And finally, just-in-time production. Just-in-time production is possible with the help of seamless technology. Seamless knitwear, in addition to the well-fit and comfort, have sustainable benefits of knitwear then consumes only the material required to produce a single garment. Since Shimaseki developed whole garment and Stoll developed knit and wear technology, it is possible to start the production process with a yarn and end up with a garment without cutting and sewing. Now many fashion wear are being developed with the seamless technology. Looking back, when seamless knitting technology was first launched, it was mainly used on synthetic materials. With continuous upgrades to the technology, it can now be applied to an even wider range of fibers, especially expensive. With the seamless knitting technology, consumers can enjoy a more natural feeling when wearing clothing made from more expensive natural and renewable fibers. And going to the conclusion, it can be said that most wasteless and sustainable weaving is circular weaving, when woven fabric is manufactured like a circle tube directly from creel. The fully fashion knitted technology shortens the manufacturing process and reduces material waste of the cutting operation. Seamless knitting technology is even more eco-friendly as it skips the sewing and cutting stages, saving large quantities of yarns. Fully fashion and seamless technology allows us to significantly reduce the number of technological equipment, technological operations, and energy consumption required for manufacturing of a garment. It can also be described as more ethical than alternative technology, as it minimizes the need for manual labor. The seamless technology can directly produce nearly finished product. Currently, the most widely available seamless garments in the market are knitted ones. Here you can see the list of references that can be interesting and useful for self-studying. So thank you for your attention. I hope you enjoyed the lesson.